Greetings, programs. We're going to be handling a LeetCode problem today. It's called TwoSum. It is my second attempt to record this, so you will see that on the page here, it shows that it is solved. I went ahead and tried to record this once and had some audio issues, so we'll run through it again real quick, just so I can get a good cut here. So TwoSum is an easy problem, given an array of integers, nums, and an integer target. Return indices of the two numbers such that they add up to target. We're guaranteed that there's going to be one solution for every answer, and because of that, we can just run through it and not have to worry about, extra cases of, well, what do we return if there's nothing? So that makes some things a little bit easier. So let's go ahead and get started here. So our first attempt at this is going to loop through the array and then loop through it again to check every value against the number that we're currently looking at to see if they add up to target. And if they do, we just return them. So we're going to go ahead and we'll say for I first in nums dot iter dot enumerate. That's going to get us the index I and then the value first. And then we're just going to do this quick because it's not the best answer, but we can just say for j and second, right? In nums dot iter dot enumerate. Now the other way that you could do this, which would be a little bit more succinct, would be to just loop through. We could just say for I in 0 to nums dot length, and then j and I to nums dot length. Let's just do it that way. Here, we'll do it that way there. For I in 0 to nums dot length. And then we'll do the same thing for j. Okay. So now we have an I and a j, which are indices, right? They're u size. So we'll have to cast them down to I32s because this one wants us to return a vector of I32s. But what we need to check first is if nums I plus nums j is equal to target, right? And if it's equal to the target, then we can create a new vector of ij as an I32, and then j as an I32. And we can actually just say return right there. And there we go. Otherwise, we just return a blank vector because we should never get there. We should find one that at least we can return. So then we'll just say vec and return that. Okay. Let's go ahead and run that. And 0, 0 is what I get. Expected 1, 2. Oh, because I'm looping through from 0. I forgot to make that be an I. There we go. Still getting 0, 0. I plus 1. Gotta go to the next index, Jason. I plus 1. There we go. All right, 1, 2. And there you have it. So that's the solution to that one. It has a order of n squared for the runtime. It's a order of n1 for the memory. It's really just two integers to loop through with. Let's go ahead and submit that just to see as it pops up here. accepted. The runtime's pretty 13 milliseconds. It takes a long while to go through order of n squared. But our memory's pretty good, 2.4. So how could we speed this up? Because if you look here at the description, it's going to ask you, can you come up with an algorithm that's less than the n squared time complexity? So they already knew we were going to do that first. And we can. So the easiest way to start speeding something up that takes for loops is to start storing some of the answers. So let's go ahead and use the collections hash map. And we're going to store these answers now. So let me call it map. Now what we're going to map here is a I32. This is going to be the value that we're looking for to complete our equation of target minus our number, right? So let's say that our target is 9 and our number is 2 right here. Then our key is going to be 7, the number we need to, make 7 plus 2 equal 9. That way, if we run across a 7 anywhere, then we can just take the data out. And what's our data going to be? Our data is going to be a U size, because that's the Rust way of handling indices, an unsigned size data type. And that's going to be the index into the array. And then when we pull that back out, we can go ahead and cast it to an I32, because for some reason LeetCode seems to want an I32 instead of the index. All right, so we're just going to make this a new hash map. All right, now we don't need to loop through twice. We're going to loop through once. But we're going to use the iterators, so we're just going to go ahead and change that to I and current value. Okay. Then this becomes nums.iter dot enumerate, so we can get the index and everything. There we go. All right, so what we're going to do first is let our find value, which is a I32, because it's going to be the subtraction here, equal target minus current. And that's what we're trying to find. Okay. So what are we going to do here? We're going to first check and see if we have a value. So match map.get. And if we have the value of, let's see, we want to see if our current value is in there. So if we're looking at, like down here, if we're looking at 2, is 2 in our map yet? Have we found anything that is looking for 2 to complete its solution? Well, for 2, it's our first one, so no. Are we looking at 7 for anything that's going to complete our solution of something plus 7 equals 9? Yes, 2. So that would be our quick and dirty answer. So we're going to go ahead and say on the current value, now we're doing an iter enumeration there, so that's a reference, and map.get is looking for a reference, so we don't have to do anything there. Just match it, and then we're looking for sum of what? Sum, we'll call this our second index. We'll call it j. Okay, that way we can have I and j. And then we're just going to say return our vec of our j as an I32 and I as an I32. Okay, but what happens if we don't find anything? Then we add it and we move on. So we add it to our map by doing map.insert. Our key is our find value. And our data is our I, our index. And then we just loop on through until we find it. And we have this here just to catch it, but should never get there. Okay, let's go ahead and run this. See if we have any things we got to fix here. Oh, we're getting out references. That's right. Okay. So we take our references and we dereference them. I don't think I is a reference there, because that's the index value. I think only the current is a reference. So we'll go ahead and run that. We'll see if I'm right. I am right. Okay. So case 1, case 2, case 3, all solved. So we're golden there. Normally I would go ahead and do more test cases, but this is an easy problem, so let's go ahead and hit submit. And there you go. We blasted away to runtime, 0 milliseconds. And our memory is at 2.71. So we had, I think, 2.4 before. So not much of a memory increase, but a great runtime increase. We're in order of n for runtime, so we're only looping through once. However, because we're storing every single item into the hash map, our memory is order of n as well. If you have something that doesn't care how long it takes to run something, especially if it's a giant amount of data, but is very memory constrained, use the first solution. But otherwise, I would just use the second solution here. The speed beats it out, and you're really not adding that much to memory. But yeah, and that's all I have on that one. So thanks for coding with me, and I'll see you next time.